Welcome back. In the previous part, we installed a fresh copy of OPNsense. In this part, we'll configure the router. But first, I think this is a good point to start spinning up a new sandbox client installation using Linux Mint. So, let's go to the website linuxmint.com and download the ISO file. You can choose whether you want to install the client directly or just use the live edition without installing. I'm opting to install the OS so I can take snapshots and easily revert to an earlier state if needed. Let's get started with the router. First, make sure you installed all updates provided by the OPNsense team. This is very important before we continue. After rebooting, go to System, Settings, General. These settings are for the router itself. It does not affect devices on the network. Change the hostname. Allow DNS server list to be overridden by DHCP on WAN, and check the option Do not use the local DNS service as a name server for this system. Save the changes. Let's tweak the settings of our interfaces. Let's start with the WAN interface. Let's prevent accidental removal by checking this. Now, let's make sure blocking private networks and bogon networks is disabled, since we're behind a home router, of course. Next, let's talk about DHCP for IPv6. I'll assume your internet provider is handling prefix delegation. Prefix delegation is a process where your ISP assigns a large IPv6 prefix, say a 62-bit prefix, to your router. This allows your network to divide that prefix into smaller subnets, giving each VLAN or subnet its own address space. With a 62-bit prefix delegation, I can create 4 separate networks and assign VLANs to each of them in a later stage. Why do we do this? Because the router sends out router advertisements to inform client devices about network parameters. By sending prefix hints, we're suggesting to these devices which IP version 6 prefix they should use for their own address auto-configuration. This helps streamline network setup and ensures devices get the correct address space for their VLAN or subnet. Save the changes. Let's go to the LAN interface. Set IPv6 to track interface and leave, at the bottom, the parent interface to WAN. We are doing this because we're behind a subrouter. Assign prefix ID 1 to prevent the adapter from using the same prefix as the WAN interface. Enable manual adjustment of DHCP6 and router advertisements. We're going to need that for sure. Save the changes. Let's go to the overview page under Interfaces and click the magnifier for the WAN interface. Look for the dynamic IPv6 prefix received field to make sure if the delegation was successful. Now it's time for setting up DHCP correctly for our network. We'll be using DNS mask for this lab. Go to Services, DNS mask. Make sure the interface only listens to the LAN interface. Under DNS query forwarding, make sure forwarding queries is disabled. Save the changes. Now, go to DHCP ranges. You'll notice our initial IP version 4 scope is already present here. Let's add a scope for our IP version 6 clients so that they can reach the internet. Click the plus icon and make sure you select the LAN interface. Fill in the scope. Start at 1000 and end at 2000. Make sure to select the LAN interface as the constructor. Save the changes. Apply. We're almost done with our global unicast addresses DHCP configuration. The last step is setting some DHCP options. Go to DHCP options and click the plus button. At the option 6 dropdown, Select DNS server, which is option 23. The value should be the addresses of our future domain controllers. DC01 is FD 50.10.10.10 with host 11. The IP addresses should be in brackets and separated by a comma. Check force. Click Save. Apply. Let's not forget our DHCP version 4 config. Let's do the same thing, but now do it for the IP version 4 stack. Select DNS server, which is number 6, and provide the IP version 4 addresses of our future domain controllers. Again, select force, click Save and Apply. Now we need to make sure we did a good job. Let's force the vSwitch adapter to renew its IP address. There are multiple ways of doing this, but in my case, the easiest way is going to ncpa.cpl and disabling enabling the switch adapter. Great job. Our sandbox client is receiving an IP address as well. Very nice. It is now time for taking a snapshot of our virtual router and change its resources. Shut down the VM. Make sure you click Shutdown, not Turn Off. The installer of OPNsense requires 4 GB of RAM. Now we can lower the amount of resources for the router. 1 virtual processor and 2 GB of RAM should be enough. Let's create a snapshot. As you can see, I already made quite a few. In your case, make the snapshot and give it an appropriate name. Amazing! We've successfully configured our router. That was an important preliminary before setting up Active Directory domain services, so congratulations again. In the next section, I'll guide you through installing and configuring our first domain controller, a crucial component for centralized management and authentication. This is the moment when our network officially comes to life, connecting everything together and making it work seamlessly. See you in Part 6.